Well, hello, boys and girls. All right. Anyway, uh, what we're going to do today is another little special topics class that I want to talk about. And since some of you were making games that had kind of procedurally generated environments, and we're talking about using tile-based systems, I want to talk about an approach to a system that is similar to tile-based worlds, but is what I call block-based worlds instead of tile-based. And there are a number of advantages, but let's do a quick review of what we did previously. So previously we were using tile-based world for rendering these large game world spaces. Those tile-based systems essentially used a grid of tiles that each is placed to fill a texture from some tile type onto the thing, and the tile types can be determine how you interact with them. And our previous example, we used those two character strings to represent the tile types, like B1, L1 for ladder, B1 for brick, G1 for grass, or whatever. And all of the textures and tiles were the same size, same dimensions. In other words, they were little squares that we put together. And we just tiled the whole thing with those squares. Now, as a quick reminder of how we did that, we had like B1 was bricks, L1 was ladder, G1 was grass, I1 was ice, and we basically just built our world out of sticking those tiles together. And so the maps were created by creating the list of the strings, B1, 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 and so forth to make a row of bricks, and we stored that in memory. Now, that resulted in something like this. We have a map string that looks like this. That creates this world, and then the eyeball kind of isn't represented in the tile. It's a kind of its own sprite entity that then can still interact by colliding with the things. And then we get enemies that interact by colliding and so forth. Now, we use that to make a large world by making a very large string-based map and then having a window into it, like we show here. There's a window into that map, and here it is being rendered, and our character is right there at the very center of the camera that moves around on that large map. Oops. And in order to do that, well, we needed a way to convert between world coordinates and screen coordinates, and we came up with a simple way of doing that is if we have the window, the objects world X and world Y, and we want to convert to screen X and screen Y, we just subtract the window X and window Y, which is this upper left corner, from that. And then to convert the other way from screen to world, we just solve that the other way and do object screen X minus or plus window X, object screen Y plus window Y, and that gives object window or world X and world Y going back the other way. So we have just doing this either a subtraction or an addition, we can either convert. And really, when it comes down to it, is we're finding the distance between here and where that object is. So really, we're just finding the difference between the X of the object in the world and there, or taking the screen to that and adding them together to go the other way. And so that gave us the ability to convert fluidly between where is this thing in our world, which could be any size and much larger, to where is it on the screen. And if we want to go back the other way, where is this point on the screen in the world? We just solve that the other way. And we did that in our previous examples. Now, the thing about tile-based worlds is they're great for creating those large worlds and we can change the world by just changing the data. So in other words, looking back at this map, if we just change where there's a B1 and an L1, we can add a ladder. You can also make it so that the player or the entities can interact with the world. Like you might have a bomb blow up, you could take out parts of the world map here and get rid of them, and then have a hole in the platform where there wasn't a hole before. Or allow the player to dig, or allow you drop a freeze bomb, parts of it turn into ice. When the ice thaws, it goes back to bricks again. So things like that are possible by interacting with the tile-based world. Since it's just stored in data, we change the data, it changes things about the world. All right, so the good thing about tile-based worlds is that they can be changed just by changing that data representation. The world size can be quite large. You can make it a really big world, like a game like Terraria. The graphics get tiled automatically by the code that we wrote to go through that. And no graphics editing is really needed to change the world. In other words, we want to change the world. You might need to edit graphics to change what the tiles look like, but to change around the platform of the world, and you want to add a platform here, add a ladder here, we don't have to edit any graphics. We just edit the world string. Now, the bad thing is about tile-based worlds, it's restricted to a grid of cells. It's restricted to the same size or multiple size tiles, and all the tiles have to be processed even if they're empty. In other words, when we go through the screen rendering things, we've got to go through every tile on the screen to say, hey, what's there, what's there, what's there, what's there? Oh, here's a brick, draw the brick. Here's a ladder, draw the ladder, and so forth. And also, if the world gets large enough, we're going to use a pretty large amount of storage, because we have to store, at a minimum, these strings, this string, which is a 2x2 array that's holding all of that data. And if we have something that's a really large world with a lot of blank space in it, you're going to be storing a lot of spaces with empty strings or nothing in them by doing it that way. Now, today what I want to look at is a little bit different technique, but that's related. And it overcomes some of the bad aspects of the tile-based grid method. But there is obviously a trade-off there. But we're going to look at this idea of what would be a rectangular block world. In this method, we're going to define our world not as like a grid of cells that are either filled in with one texture or another, but we're going to store it as a list of rectangular blocks that make up the world. And each of those blocks is rectangular, meaning it has an x, a y, a width, and a height. But notice that unlike with tiles, the width and the heights can vary. They can be different for each of the blocks. So in other words, rather than thinking of it as a whole bunch of squares, think of it, you could have some that are tall like columns, some that are wide like platforms, some that are big rectangles like this, some that are kind of different shapes. As long as it's a rectangle, we can represent it with this. The other thing about those is rather than placing them on the grid, they can really be at any location in the world at all. So you could have a platform here. You can move it over by one. Not one whole tile, but 1 pixel or up by 1 pixel. You could have a platform here and one that's raised just a little bit and another one's raised a little bit to make like a ramp. So something that's harder to do with blocky square tiles, we could do geometries that are a little bit more complex doing this. Since they're just rectangles, they can have any width and height. The location doesn't have to be on a grid multiple, but it still has a texture associated with it, and it might have a collision type associated with it. In other words, you get background tiles, or not tiles, but background blocks and foreground blocks that you interact with. So here's the concept. The concept is the idea is we're going to represent each of those blocks with the simple class. And the simple class, basically, it's unlike the tile-based world where you have to have an array or a list of lists to make a two-dimensional array, essentially. In this case, we just have a single-dimensional list, but it has those blocks placed inside of it. So the idea here is with this block class, it has an X, a Y, a surface, and then whether it collides or not, and what collide type or collide group it is. And so the X and Y is just where it is. The height and width is how wide and how tall it is. The surface that goes with it is the texture. And then collides would either be true or false. And the collide type would be a way to give it a kind of group name for a collide. So you have collide and make it like a solid ground. You could have a collide type that is a ladder that allows you to climb or something like that. So we're going to allow that to be flexible and have different, you can think of it as collider groups that you can assign. And then what we're going to do is we're going to make another class that's going to keep track of those blocks. And that's going to be the one that is kind of renders them all, checks for collision, and allows us to interact with it. So that's going to be more like the grid, but it's just going to be a list of them. So here's what the block world looks like. And looking through that code here, let me hide my face so you can see all of it. But looking at this code, you'll notice we have this world object, which we're calling it. And all it has in it is has the screen left, screen top, screen width, screen height. So that's the actual screen. And then the world itself has a height and a width. And there's the screen. The screen is essentially the window that's placed into the world. And the reason this has a left and a top and a width and a height is that allows us to place the window anywhere we want in the world when it starts up. The block, and then we have finally the block list. That's a list of the rectangular regions that are all going to be available for us to use and build things with. And then we have the ability to add a block, which adds something to the list, which allows us to dynamically change the world while we interact with it, make blocks disappear, add new ones to it. And then we have the ability to render the blocks, which basically just goes through every block in the block list and blitz it onto the surface. And then I added this thing to draw a rectangle around the perimeter of the world, the outline of the entire world itself. And then we have our collision routine, which basically goes through every block in the blocks list, sees if the rectangle we're requesting that collides with actually collides with it, with that block. If it does, then we add the collide type of that block to this list, collide type list, and then at the end we return the types of everything that we're colliding with currently. And then we return false if the list is empty. We could return an empty list. We could return what's in the list. I just returned false if it was empty. All right, so that's not a whole lot of code. We have this, looking back at this, we have this block object class, and we have this world object class. And that's really all we need to build the thing. So to create a world, we just need to load some images and then create blocks for them. So we're going to load some images, create a block world object instance, and then add blocks to that using add block. And you can really add the same texture in different places because each block has its own X, Y position. Another cool thing about this is you could actually create it so that those blocks that you add, you take one image and then do pygame.transform.scale and scale it down and make the sizes different, have some small like platforms and some larger platforms or something like that. But after we have that, we're going to render them with the render blocks method, and then we're going to do collisions or check collisions using the collide blocks method. All right, so here are some examples of the kinds of things that you can add for blocks, and this shows how this is a little more flexible than tiles. So here's a tile, but let's say we don't want everything to be that size. We want some vertical columns like this. We want like a platform that's made of steel like that, maybe a girder thing that's like that. And these are just some things that I threw together quickly. But notice that this girder can be a shorter length than this one. And notice that they're not all squares. Notice also the textures you put on here can be more elaborate because they don't have to tile like they do with a tile-based system like this. So note that the blocks could be different sizes, and we could set some to be, like if we wanted these columns to be in the background where we run and go across the surface of them, and they just show up, they're just a visual element. You could certainly do that where you would interact with these platforms or these bricks. And for our example code, we're just going to load the images and then randomly create the world. And some of you, since in your projects you mentioned having kind of a procedurally generated map or world, that's what we're going to do. So here's how we're going to create the world. We're going to load up brick, beam, metal beam, and pillar. And then I'm going to create 30 of these pillars. Notice I'm setting the collision of them to false, so they're not colliding. And then I'm creating bricks, beams, metal beam. I'm creating those, and I'm putting them out, all of those at random places within the world. All right, so let's code it up and see it in action. Since I want to keep the lecture short today so you can focus on your thing rather than me live coding all this, I already have this coded up, so let's just take a look at it. So we could write the code or cut and paste this together and see it, but since I've already done that, I'm just going to switch over and load that up and go through that code quickly, and then we're going to run it and see it in action. So give me a second here to bring that up. And then let me switch over so you can see that as I code it, or see the code anyway. And before I do that, hold on one second. Let me change the font size so you can see this easier. All right, so let me switch over so you can see what I'm doing here. Okay, so here's the code. Let me make this a little bigger so you can see everything. Put that right about there. And actually, let me make this a little... That was the dog stretching, if you wondered what that noise was. One of the dogs, anyway. Okay, so here's the code, and I will post this to the course page so you can download it and play with it. But notice here's that block object. As we said, very simple. Just has an X and a Y, a width and a height, and a surface that goes with that. And notice it gets the width and the height off of the surface. In other words, in this case, it's just matching whatever image we pass into it as the size of the block. But we're placing it into the world at this world X and that world Y. And then we're setting it to either collide or not, and setting the collide group or collide type of it. And here's the world object, just as described. We have the constructor that creates the empty block list. Add block will add things to it. Render blocks will show them. And then collide blocks is the one that returns the list of what kinds of things we're colliding with. And then down here, I've created a player object which has an X and a Y, which are somewhere in the world. It has dx and dy, which is kind of the motion vector of it. Has a surface, which in our case we're just going to use that eyeball again, and a width and a height. And then we have render, which renders it. I move left, move right, hover, which kind of makes it go up the screen like a jetpack, jump, which is checking if we collide with blocks in the world or not. And then the update, which essentially moves its position, which is all stuff we've done before. I also have this blob object thing, which is a world object that's going to come after us or fly and try to catch us, that I added. But down here, again, here's where we loaded some images. We created a block world class instance that is 10,000 by 10,000. So this is a very large world we're creating. And in that world, we're adding 30 pillars, 200 bricks at random places, and then 40 each of the horizontal metal beams and the kind of grid or truss beams. So we're just adding a bunch of those. Here's the eyeball we're creating for the player. We're creating this blob object. And then here's my main program. All I do in the main program is essentially at 60 frames per second. I pump the event queue. I get what keys are pressed, and if they're pressing A, I move the player left. If they're pressing D, I move them right. If they're pressing E, I hover. If they press space, I jump. And then here we are converting the, this is making the camera follow the player. We talked about doing that in previous lectures as well. This one's using the mode where it just kind of pushes the screen around when you get near the edges. And then I have this blob that's moving towards the player. Notice you can have the blob move towards any position on the map you want. And then down here, the main part of the code where I render stuff is I render the blob. I render all of the blocks in my block world. I render the player. And then here, I update the display, and that's it. I go back and do it again. So very simple code. Let's look at it in action. So there it is in action, and since it's a randomly generated geometry, I fell a long way there. Notice I can press spacebar to jump. I can use the jetpack to hover by pressing E. But you'll notice that this world has things that are in the background, like the pillars are in the background. Oops. But notice how large this world really is here. Let me hover around a little bit. And you don't have to generate the world randomly. You could generate the world, and notice that as I'm hovering, I still collide with stuff and run into things. I can still jump. And this being created randomly might create some issues with the geometry, creating areas you can't get to or things that don't make sense. But you can create these rather than randomly. You could create it with like a map editor that you create, or you could create them kind of like you do with the tile method. But notice the advantage of this system is that you can have a really large world space that this player is still moving around in. And you don't have to have it all just be grid tiles. It can be any, the items can be any, at any position you want them to be. And in fact, we haven't even seen the edge of the world yet. Let's see if we can keep going down until we get to the bottom. Okay, and there's the bottom of the world where I put that red rectangle. And if we keep going to the left, we'll eventually get to the left. Oops, we gotta jump over that. Eventually get to the left of the world. But notice how big this world is. Here, this is 10,000, essentially 10,000 pixels wide. Let's walk from this side of the world all the way to the other side. So here we go. And I'll try to jump over objects as I come to them. That was a little bit late on the jump there. And there we are to the other side. And there's no reason why we couldn't make this world bigger or add more items to it. We use the jetpack to get up here. Oh, and there's the blob that's actually trying to get us. So you'll notice that it's moving towards us. And it should eventually catch up with us down here. It's up there somewhere. Oh, there it is. So the blob moves relatively slow compared to us. But if you'd imagine an army of them coming at us, then suddenly we'd have a game that's more of a challenge. I'm going to try to jump over the blob. So you can see how that could become an enemy in the game. And right now I believe the blob object does not care if it collides with geometry in the world. So I think it'll go right through that brick. We'll find out here in a second. Yeah. But we could make it so the enemies in the world interact with the geometry just like we do. But I think you could see how this method could be used to do some interesting things. Especially involving really large worlds. And as you can see here, this would qualify as a really large world. And I'm actually not entirely sure if there's a way to get all the way to the top here. I keep running into beams. But you can kind of see how you can make there. Okay, now we're at the top. Here, let's see if we can drop all the way down somewhere here. Oh, we hit a beam. So you can kind of get a sense of how big this world really is. And you could, instead of this, you can make it 10 times bigger than this if you want to. It'd be very easy to make this world any size you want it to be. And you could do very pretty graphics in the background, like we have here, that you scroll over the top of. Now, there are some disadvantages to the tile-based world that making a map editor gets a little more challenging because everything is different sizes. Getting things to line up could be a little more difficult. But this is an alternative to those tile-based worlds. And I've used these for this idea for projects. And for the certain kind of project with a large world where you don't want to be constrained with sizes of tiles, this can be a really useful method to do that. It's also very easy to add camera control. So you could have the like for a real-time strategy game where there's a battle going on here, but also somewhere else. You could click on the mini map or say go to the other thing, and the camera could zoom over to the other location and look at what's going on there, and then zoom back to here. And because we are not constrained by a tile-based system or a grid system, you can have things line up in ways that otherwise you could not have with a tile-based system, and things that are different size. Like for example here, notice how big that pillar is. Notice how many tiles it would take to make something like that. Now, one other thing is the last thing I'm going to mention here, is note that you could expand or extend this concept and do a hybrid system where you use block-based system like these pillars for the background, and then tiles like these in the foreground. And you can make those scroll at different rates, which that gives you a technique called parallax scrolling. And if you've played, there are a whole number of platformer games that work like that, where you have the background scrolling at a slower rate than the foreground, which gives the illusion of depth with things moving in the foreground and things moving in the background. And so you might want to consider an approach like that. Use the block-based system for the background imagery, trees and pillars and a sky and a moon or whatever that's in the background, and then use the tile-based system for the foreground, and then have the scrolling rates slightly different from each other to give that illusion of depth. And so that multi-level scrolling or parallax-based scrolling can give your game a really high level of polish. And then you wouldn't have to worry about creating all of the tiles to make something. This would be just dozens of tiles that would all have to be put in there in the right way to make this object. But in a block-based system, just load the graphic, stick it where you want it, and bam, it shows up in there without us having to tile all that, or fill all that region in. And then if you wanted, you could lay a tile-based system on top of that to do the geometry for these like little platforms and things. Okay, that's the code. Let's switch back to the presentation for just a second here. So we coded all of that up. I will post that code to the website. So the summary, the block-based system provides this alternative way to represent large worlds that don't have the limitations and restrictions of tile-based worlds. There are some disadvantages. One of them is that the block-based system, notice it could, because the geometry can overlap, that can create some issues as well. And also, it's a little bit less efficient because in our render loop, notice we were going through, it had to go through everything in the list in order to know. We're essentially blitting every image in our block list. It's just so happens that if the block is off screen, Pygame kind of ignores the blit call, but we're still making the call. And so it's a little less efficient. Now, there are ways to make it more efficient by dividing up your world into kind of region areas, and then having those assigned to where the blocks live, where they're visible from, and then only checking ones that match the restriction, or checking a collision with the screen rectangle versus the blocks themselves and saying just ignore the ones that are outside of that. So there are ways to improve performance of this, but overall it's a pretty good system, especially for very large worlds that we want to represent, where we don't want to have the restrictions of the tile-based system. And also you could use it in conjunction with a tile-based system, rectangular blocks for the background, tiles for the foreground, or vice versa, or both tiles and rectangular blocks stuck into that world. That would work as well to do that. So here was the example we just did with a little eyeball falling through the procedurally generated world. And that's all for today. Work on your projects. I will post this code if you want to load it and play around with it and load up some different items and put some things at different places. We came in right about where I wanted to at the 30-minute mark. We had some long lectures last time where I live coded stuff, so this time I want you to work on your project, so I made it a little shorter. So work on those and take a look at this code. It will be posted to the course page. If you want to take a look at that, feel free to do that. If you think it'll help with your project or you're not quite sure, as always, I'm here to answer questions and help. And hopefully in the next few weeks, we're going to have some time to have a few more lectures, like special lectures that I want to go over, special topics kinds of things. But if you're starting to run into problems on your project or questions on there that I'm not answering with these videos, let me know, because I really want to make sure you're successful with those. All right, so that's it for today, and I'll see everybody next class, where we'll cover another topic that I think will be helpful, and you'll have more lab time. But in the meantime, work on those projects. Don't put it off. We're down to the final 3 weeks. You can get a lot done in 3 weeks, but don't wait till the last couple of days and then try to get everything done. This should be a nicely polished, clean, working program that you get for your project for this year. And I really want that for your portfolio, and something for you to make something that you're happy with and proud of. So work on it. That's it.